Welcome back to Chem 101. In this video, we are going to be talking about Avogadro's number, otherwise known as the chemist's dozen, or more scientifically known as the mole. And what Avogadro's number is just a really big number. It's a 6 with essentially 23 zeros after it. You might see it in scientific notation like this, but when we talk about atoms and molecules, because these things are so tiny, and even a grain of sand contains so many atoms in them, it doesn't make sense to talk about them in actual numbers. So every time we have 6 with 23 zeros after it worth of anything, we're going to call it a mole. That goes for atoms or molecules. It even counts for everyday objects like cars and kittens. So let's look at the mole and how we can use it.
All right, so Avogadro's number. This is 6.022 times 10 to the 23rd of anything. Well, this is just what the definition of one mole is, rather than anything. But the mole can describe anything. So this is equal to 1 mole. And we're basically just using mole like we would use dozen. So 12 of something is equal to a dozen. And if I had 110 pizzas, and I wanted to know how many dozen pizzas I had, I could say, well, I know that there are 12 pizzas in 1 dozen. Or I have 9.17 dozen pizzas. Now, in this analogy, I'm just showing how we can talk about a dozen of anything. And we can actually use the fact that 1 dozen is 12 to convert between things. Or I should have circled this rather. So we're going to treat Avogadro's number the exact same way. So let's do some examples of that. First, let's talk about some large number of something like atoms. Let's talk about a large number of atoms. Let's say that we have 8.00 times 10 to the 18 atoms. And we wanted to know how many moles that was. Well, we'll simply use our mole conversion here that says if I have 6.022 of anything, even atoms, 6.022 times 10 to the 23 atoms, but that's 1 mole. There we go. And so what's that going to equal? Well, we're going to convert out of atoms, and I get 1.3 times 10 to the minus 5 moles. Or that number would look like this, 0.000013 moles. So that's just going from atoms to moles. And in this case, we can kind of tell that because we only have 10 to the 18 atoms, and 1 mole has 10 to the 23 atoms, that we shouldn't even have a full mole, and we don't. Alright, what if we have a larger number? How about 1.79 times 10 to the 40 atoms? Or not even atoms. Let's change that. Let's say molecules. We gotta decide what these are. Molecules of water. So we have that many molecules of water. How many moles is that? So we'll say 6.022 times 10 to the 23 molecules is 1 mole of water. We gotta put water here, right? Molecules of water is equal to 1 mole of water. So now we can see, again, 6.022 of anything is 1 mole. And in this case, we're talking 6.022 times 10 to the 23 molecules. That's just 1 mole of water molecules. Okay, so how many moles is this? We just divide 1.79 times 10 to the 40 by 6.022, 10 to the 23. And our answer comes out to be, it's 2.97 times 10 to the 16 moles of water. Moles of water molecules, for being very specific. All right, well, let's string more than one of these conversions together. Let's try something else. Let's try this last one where we string a bunch of conversions together. So how many hydrogens atoms are there in 2.58 grams of water? Well, let's see. 2.58 grams of H2O. Now we're going to use the formula mass of water, which is equal to 18.02 grams per mole. And if you're unsure how to calculate a formula mass, watch the video on formula mass. So we're going to say 18.02 grams per mole is, sorry, we don't need grams per mole. On the bottom here, we're saying 1 mole like that, grams per mole. And we can use our conversion factor like this. Mole of water. We're talking about water here. All right, now that we're in moles of water, we're going to use Avogadro's number and say 1 mole of H2O contains 6.022 times 10 to the 23 molecules of water. And we want to go into molecules of water so that we can go into atoms of water, because we know that 1 molecule of water has 2 hydrogen atoms in it. It also has 1 oxygen atom, right? H, we've got another H, and they're connected to an oxygen atom. It's got an O, right? So a water molecule has these 3 atoms in it. And so one molecule of water has 2 hydrogen atoms. We can say that. All right. So what's the answer? So this has 1.72 times 10 to the 23 hydrogen atoms. So that's how many hydrogen atoms there are in 2.58 grams of water. We can do one more quick one. Let's say we started with something like 6.33 times 10 to the 18 atoms of hydrogen. And we wanted to know how many grams of water would contain that same amount of hydrogen. We would have to do a problem like this. So we would start with our number. Let's move it over a little bit. And we would say, well, I know that there are 2 H atoms in 1 molecule of water. And there are, let's see, 6.022 10 to the 23 molecules in 1 mole of water, and 1 mole of water, H2O, has a mass of 18.02 grams. And so we would then know the mass after units cancel, right? Atoms of H, molecules of water, moles of water, and we'd be left in grams. 9.47 times 10 to the minus 5 grams of hydrogen. Oh, sorry, grams of water. That's how many grams of water would contain that many hydrogen atoms.